Hi guys! Ang unang method na pag-uusapan natin for this chapter is the Euler's method. So this is considered as the simplest method in obtaining numerical solution nga for ODEs. So sige, simulan na natin yung discussion. Euler's method is considered as the simplest way of performing numerical solution to a first order differential equation. So ODE nga siya. Although this method is not accurate nor efficient compared to the other methods which will be presented later on this book, it is useful for understanding the numerical processes for ODE. So, dito pa lang sa statement na to, sinabi na class na this method is the simplest way. However, this is the least efficient. So, most programmers and engineers rarely considers this kasi alam nila na itong method na to is nagbibigay ng less accurate na answer. However, for educators like me, ito yung una naming tinuturo as introductory nga dito sa lesson na to for differential equations kasi yung lahat ng remaining methods is na-derive from the Euler's method. Okay? So ulitin ko lang for practical application, hindi to masyadong nagagamit kasi nga it is found out na hindi nga to accurate. However, for the purpose of teaching, ayan, nile-lesson pa rin to as an introduction for numerical solution ng mga first order ODE. Okay? So, ito yung magiging equation natin. Kung i-consider natin differential equation dy over dx is in a form of f of xy. So, this is a function both for x and y. Let the initial condition for the differential equation equals xo, yo. So, di ba? Sa differential equation, kapag first order, meron tayong kino-consider na initial condition or initial value. So, that is an ordered pair. So, to solve for y sub n plus 1 of the ODE, given a step size h, so may i-consider tayo ditong step size, the formula is, so ito, y sub n plus 1 is equal to y sub n plus h, the quantity f of x sub n, y sub n. So, kumbaga, the future point is equal to the previous point plus h, tapos itong function from the differential equation. So, para mas maintindihan nyo, let's discuss an example here. So, ito yung example na nakikita nyo. Basahin ko lang siya. Consider a differential equation shown below. So, y dy plus 2x dx equals e raised to x dx. So, solve for the value of y when x is equal to 2 if 0, 1 is part of the equation. So, ngayon class, gusto ko lang i-emphasize na itong 0, 1, ito nga yung tinatawag natin na initial value. So, di ba? Kasi kung maalala nyo, dalawang methods pala ang gagamitin natin. The analytical method, this is the old school method or the traditional method, while the Euler's method, this is the numerical method. So kung maalala nyo kasi, for the analytical method, hinahanap natin yung general solution, tapos may isa-substitute tayong initial value para mahanap nyo yung particular solution, di ba? So, I hope naintindihan yung mga terms natin for differential equation, no? General solution, tapos kapag may initial value, gagamitin mo yon para mahanap yung particular solution ng differential equation. So, nevertheless, ang assumption ko dito, may basic understanding ka na ng differential equation and of course, calculus kasi sa analytical method, yun yung gagawin natin. If you are experienced enough to solve differential equation, alam mo na yung given na differential equation is variable separable. So sa lahat ng first order, ito ang pinakamadali, separable. However, di ba, meron tayo dyan kino-consider pang homogeneous, exact, non-exact, first order, and Bernoulli, as I said nga. But, yun na nga, ito daw na equation natin, itong differential equation na to, variable separable na siya. So, in this case, isosolve natin yung general solution. So, ito yung original DE. Ang gagawin ko, lahat ng Y, igugrupo mo. Then, lahat ng X, igugrupo mo. So, pag ito, nilipat mo sa kabila, so, ito na siya. Magiging e raised to x minus 2x dx. So, ayan na. Then, perform integration on both sides of the equation. So, the integral of y dy is equal to the integral of e raised to x minus 2x dx. So, madali lang naman i-integrate ito. For instance, the integral of the first one is y squared over 2, and that is equal to ex minus 2x, e raised to x minus x squared. So, kasi yun yung integral nito, plus, of course, the arbitrary constant c. And, of course, class, pag cross multiply nyo, yan yung mangyayari, di ba? Kapag nag-perform ka na ng cross multiplication, y squared is equal to 2e raised to x minus 2x squared plus c. Eh, di ba sir, dapat 2c siya? Oo, tama ka naman. Dapat 2c siya. Kaya lang, kung maalala nyo kasi, this is for the general solution, 2c is equal to c pagdating sa sa differential equation, di ba? 2c is palaging equal to c. Ang e raised to c nga, kino-consider na rin natin yan as constant. So, ganun yung natin, di ba? Ganun yung understanding natin sa differential equation. So, alam ko na yung iba magtataka, sir, bakit hindi mo to ginawang 2c? Again, this is a differential equation. So, constant multiply by a constant is still a constant. Kasi ang goal pa lang naman natin dito is to solve for the general solution of this differential equation. So, I hope that gives clarification na. So, ito na yung general solution. Okay? So, ngayon, ilagay ko lang siya, no? Ito na yung general solution. Ang next goal mo is mahanap yung particular solution. And paano natin yun gagawin? So, since meron tayong given na initial points, which is 0, 1, isa-substitute natin yan para mahanap yung C. So, as simple as that, sinubstitute na natin. And the value of C is equal to negative 1. So, pag in-evaluate nyo siya, C is equal to negative 1. And therefore, dahil may C ka na, ito na class yung particular solution ng differential equation natin. So, from the general, isubstitute nyo lang to. Y squared is equal to 2e raised to x minus 2x squared minus 1. So, ayan. Meron na tayong particular solution. So, ang tanong na lang dito, what is the value of y when x is equal to 2? So, since nakuha mo na yung solution, just substitute x is equal to 2 here. And, ayan na siya. Mahahanap mo yung value ng y. So, kung baga, i-evaluate mo lang to, then take the square root kasi naka-square siya. So, y is equal to 2.403770. So, ito na po ang ating analytical or true answer. So, yun. Tandaan nyo tong value na to kasi sa mga future discussion natin for this chapter, lalabas at lalabas ito. So, ilagay ko as the analytical or the true or of course, exact answer. Kasi itong answer na to is based doon sa basic understanding natin sa differential equation. But take note, dito sa ang purpose nitong chapter na to is i-skip natin itong mga processes na to dahil when we say numerical methods, syempre, gumagawa ka ng algorithm para sa lahat ng ordinary differential equations. So, let's start solving this using the Euler's method. In-indicate sa problem class na yung step size ay 0.25. Okay? So, yun yung step size. I-arrange natin yung differential equation in a form dy over dx is equal to f of xy. So, ito po yung original differential equation natin. Ang gagawin nyo lang is ma-isolate nyo yung dy over dx. So, in that case, ito na siya. Y dy is equal to e raised to x minus 2x dx. So, ang ending, yung dy over dx is equal to e raised to x minus 2x all over y. So, ito na yung function natin. So, therefore, yun na nga, f of xy, as I said, is equal to, ito siya, e raised to x minus 2x all over y. And kapag na-establish nyo na to, pwede na tayong mag-proceed doon sa Euler's method. Take note, ang goal natin sa problem na to, i-recall ko lang, yung goal natin is y is equal to what when x is equal to 2. So this is the goal of this video. So therefore, perform Euler's method nga to solve for y when x equals 2 if the differential equation has an initial condition of x0 equals 0 and y0 equals 1. So dito muna tayo sa n equals 0. Nilagay ko muna yung initial condition class, di ba? So, yung x0 is 0 and yung y0 is 1. So, ayan na. And take note, yung h dito is 0.25. So, therefore, dun ka na sa unang step. So, as you can see, ang ginawa ko na, so, n is equal to 1, x is equal to 0 plus yung step size na 0.25. However, yung magiging bagong value ng y is equal to 1 plus itong h natin, so ito yung susundan nyo, h 0.25 times, again, if you are going back, ito siya. Ito yung function natin, e raised to x minus 2x all over y. So, ito na yung magiging solution. E raised to x, ano yung initial point? Ito, tingnan nyo, 0 minus 2 times 0 all over y is 1. So, ang sagot natin is 1.25. Just continue this process. Ulit-ulit lang naman to, class. So, for n is equal to 2, 0.25 siya dati. So, dagdagan mo lang. 0.25 plus 0.25 is equal to 0.5. And yung y sub 2 is equal to 1.25 kasi ito na yung magiging value, 1.25. Plus, still, yung 0.25 is the step size. Yun na yung constant. The quantity, e raised to x, and yung x is ito, 0.25 minus 2 raised to x. So, 0.25, ito siya. All over y, so 1.25. So, ang bagong value ng y is 1.406,805. So, ganun din for, the third one, 0.5 plus 0.25 is equal to 0.75 na siya, class. And in that case, ganun din for the y, previous value is 1.406,805 plus 0.25. So, e raised to x, what is the previous value of x? This is 0.5 minus 2, tapos 0.5 all over yung previous y, 1.406,805. So, that is equal to 1.522088. Ipa-flash ko na lang yung hanggang sa ma-reach mo ito. Matatapos ka lang, class, sa ganitong process kasi that is repetitive eh. So, kung titingnan nyo, repetition lang naman yan. Matatapos ka lang kung yung x nyo for the last time is maging 2. Kasi 'di ba yung goal nyo is to solve for the value of y when x is equal to 2. So ganito nga kasimple yung Euler's method. So imbis na mag-isip ka pa kung anong type of differential equation ang given, kung separable, homogeneous nga whatsoever, i-derive mo lang siya sa dy over dx is equal to f of xy. Tapos this is a repetitive process. So ulitin ko, ang kagandaan kasi dito is napo-program siya. Yun yung importante eh. For as long as programmable, ibig sabihin, yung computers natin, class, is kaya niya nang mag-solve ng mga differential equations. Kasi baka yung iba nagtataka, no? Paano nasosolve ng computer ang mga differential equation? Ang sagot is ganito. But, hindi ito yung program na ginagamit ng computer kasi nga, as I said, the Euler's method is less accurate compared to the other methods na i-discuss natin later. But for the meantime, again, since ang goal natin is to solve for the value of x when, solve for the value of y when x is equal to 2, so dito, stop na tayo. And the numerical answer is 2.345933. Okay? So, ito yung ating approximate or the numerical answer. So, as shown in the solution below, the numerical answer is y equals 2.345933, which has a significant difference in the true or the analytical value. So the graphical illustration below, or actually at the right, shows the Euler's method perform numerical approximation of the problem. So, itong blue one, that is the analytical or the exact. So, ito yung analytical differential equation. Tapos, the red one is kung paano sinolve ni Euler yung differential equation natin, class. So, kumbaga, titingnan nyo, yung Euler is almost dumikit na, or tama ba, pumatong na kay analytical. This indicates na medyo accurate yung solution natin ngayon. But, ito ang kailangan yung tandaan. For this example, the relative error is 2.41%. Before I proceed to the next chapter, i-discuss ko lang kung paano ba dinidiscuss or paano ba sinosolve ang paano ba sinosolve yung ating relative error. So, yung formula class ng yung formula ng relative error is equal to yung x approximate or t, ano bang tama? Kasi yung iba nagtataka, no, bakit bigla na lang nagkaroon ng relative error dyan. Pero ang computation lang naman yan is the absolute value of approx minus true all over true. So, So, multiply nyo na lang ng 100%. Palagi yan na naka-absolute value. So, for instance, dito, yung ating na-compute na approximate answer is of course the numerical 2.345933. And yung true value, di ba? As you can see doon sa previous slide, yung na-compute natin is 2.403770. So, 2.403770. Tapos, divide mo na lang siya ng 2.403770. So, absolute value times 100. So, yung ating relative error nga dito is 2.41%. So, pwede nyong sabihin na, ang accurate na pala ni Euler's method, no? Kasi nakapagbigay siya ng 2.41% lang na error. But, let me point out na there are some cases daw that the relative error is very large. So, sometimes it is above 50%. Yun nga mag 10% o 5% na error is sobrang delikado na. What if about 50%? So, that is shown in the module na hawak nyo ngayon. Hindi ko na yun i-discuss kasi kung makikita nyo naman, yung solution naman is parehas lang naman nito. But yun na nga, gusto ko lang i-emphasize na ito is nagkataon lang na yung Euler's method natin is nagbigay ng magandang fitting doon sa sagot sa differential equation. But in reality, karamihan ng cases, yung Euler's method is not a good thing. So you can see in the module na masyadong inaccurate ito. For the next example, I believe that is 70% relative error, and that is very dangerous. Even nga itong 2.41, actually dangerous na yan But still, nilagay pa rin natin. So ayan, I hope this is clear. Pwede na siguro natin i-end itong video na to regarding sa Euler's method. So thank you so much for listening and watching.